Hello and welcome back to Math in 5-ish minutes with me, Ms. Wodzinski, where I break down math topics into easy to understand explanations. Today's topic is trigonometry, and we will be going through a couple examples for solving for missing sides and missing angles in right triangles. Let's go ahead and begin. We can use trigonometry to solve for missing angles in triangles. So in this triangle, we have all the sides already, but we want to know what the two angles are. So let's go ahead and just pick one of them to get started. If I want to pick angle X, then I'm going to mark angle X and we're going to label the triangle focusing on angle X. So that would mean our opposite side is over here at 12, our adjacent side is 9, our hypotenuse will always be 15. Now, since we have all three sides, you can use any of the trig functions that you want. I am partial to sine because it is the first one. There's no real reason. So again, here is our mnemonic device, SOHCAHTOA. So if I'm using sine, that means I want to use the opposite, which is 12, and the hypotenuse, which is 15. So I set up my equation, noticing that in this case, it's sine, and then the angle goes inside there, so it's x, equals 12 over 15. Now in this case, we need to find a way to take the x out of the sine function. So we have an operation in our calculator that does that, and it's called sine inverse. Like adding is the opposite or the inverse of subtracting. Sine inverse is the opposite of sine. So we are going to do a sine inverse on both sides here, and I'm going to write it like this. So this is the long version, which I will not always show, but it really works out that if we take the sine inverse of both sides, what happens is the sines cancel out and just leave us with x, and then we need to do sine inverse of the other side, which will just give us a number. So on the left side, the x comes out of the sine. On the right side, on your calculator, you're going to do sine inverse of 12 over 15, and that should give you the value 53.13, and I put a degree marker there to know that it's actually an angle. So x is 53.13. Okay. If you wanted to use either of the other two trig functions, you could have used cosine of x, and then you would have used 9 over 15, or you could have done tangent of x, and that would have been 12 over 9. Either way, going through this process, you would have ended up with 53.13. Now, of course, from here, since we have the 90-degree angle and one other angle, we could just use the triangle angle sum theorem to find y. But I'm going to go ahead and solve for y using trigonometry as well. So let's go ahead and relabel our triangle here, because now we're going to be at y, which means in this case, we're actually going to have 9 is the opposite and 12 is the adjacent. This time I'm going to use tangent. So I set up my equation, tangent, and then the angle goes inside equals opposite over adjacent, which would be 9 over 12. We need to go ahead and take the tangent inverse of both sides. So I'm going to write it like this. So the tangents cancel out on the left, and then on the right we have tangent inverse of 9 over 12. That's just a calculator problem. So in your calculator, you're going to do tangent inverse of 9 over 12, and it should leave you with 36.87 degrees, which hopefully, if you check it with your other angle, all three of those angles should add up to 180. If you chose to use either of the other two trig ratios, you could have used cosine of y, which would have been 12 over 15, or sine of y, which would have been 9 over 15. So there's a very quick example on how to solve for a missing angle in a triangle using trigonometry. As always, happy learning.